And here we are. Let me switch to the bench. And here's the bench view. Up, and both camera work. That's exceptional. And the audio works. Let me listen to it. Oh yeah, there's a huge delay of 30 seconds. Let me start. Yeah, it's been a while since I've made a stream. Yeah, audio works. It's been a while since I've made a stream simply because I've been developing a product, which I'll show you. It has an agreement to be open source, so I'll show you and explain it what the product is. But it is not yet complete. Almost there. I have to document it. But nevertheless, I wanted to make a stream and do something, and then someone said, "This is broken. Fix it." And that's all I know. So we will have a quick fix. And what is this? This is a USB to DMX converter, and it seems it has 2 outputs and 1 input. I don't know. USB to DMX standalone playback. Okay, can do playback. Yeah, it's the guy making lots of shows and so on, which I'm friend with, and who asked me to fix it. Or at least I said that this looks broken. Can I fix it? These are probably, so yeah, probably 2 outputs and 1 input, 2 universes output, and you see that this is kind of a bit more professional DMX because it has 5 pins XLR controller instead of 3 pins. 3 pins is really amateur, but it's plenty enough, and it's cheap and it's available. But 5 pins is the recommended way to be used from the one specifying what DMX is. So it looks half professional with this connector, and I think I don't have, okay, I will not be able to test this device with DMX because I don't have any converter from 5 pin to 3 pin. I'm just an amateur regarding DMX. I just know exactly how it works in the electrical way. I implemented some DMX controllers and debugged some DMX things, but I don't have any 5 pins things. But what I can do is plug it this way. So we should see everything which is on the output on one universe should be in the input of the other thing. We could do it this way. What I notice is that here this is the USB input and there is no USB connector. I think this is the only thing which is broken. I don't know. That just as USB has been quite stressed. We'll have a look at it. So let's remove this because it will be in the way. Oh, so they have their own common connector even with the brand name of this DMX module. So they spent some parts, and this is a don't know, doesn't look like DB connector. DB is larger, DE is smaller. It's maybe something in between. Some kind of D connector. Let me zoom a tiny bit for now. We don't need to see the whole space. And I'm moving the camera so it's closer to me. This one. So not self-tapping screws. Normal screws means there's probably a metal insert inside for the screws. Again, a bit more expensive than the cheapest you can find, so it looks like kind of a professional device. That's the plates. But here we have self-tapping screws. Weird that on the outside you don't have self-tapping screws, but on the inside you do. Order. Oh no, they're not. They're not self-tapping screws. They just look like it from the top, but they are not. Not too many screws. I don't have to distinguish them. There are only 6 screws. Let's get a spatula. The board looks kind of okay. Red, that's unusual. I would think that you can put green in something where you don't see the board and you don't care about the color, but they used red. And they have test points. So these test points, so probably they even test the board in situ, meaning in the box itself. Before everything is closed, they test it, and they come with pogo pins here and test everything. Although no, that can't be. I think they are just test points for debugging, but although no, they are. Okay, so here are the test points for the output. Here they are marked. I don't know why they are that marking here, but here you see other test points. Actually, they have vias, which are used also as test points, because all these vias here have, let's have a closer look, so you can exactly see what I mean. On the board, all these via here tented, meaning that you have solder mask on the via, so you cannot poke on it. Some of the vias are not tented. You see, you can access the vias and they have a larger pad. So this is where here they have added a label. So these are test points where you just come from with the needle. I should have some pogo pin needles so I can show you what it looks like. Pogo pin, here. This is my pogo pin box. It looks like this. And these are pogo pin needles. You have plenty of different pogo pins. So generally P something, it's pogo, and then the size of the tip, 7.5, I don't know exactly, mils, 50 mils. But you come with one of these. Let's just use one of these needles, for example. And this is spring loaded. They have a durability, I think it's 100,000 times, 10,000 times, depends on the price. Then you have a flying machine which comes here and puts the pogo pin on here and can test it. So you can test the board. So here they added the labels, here they didn't add the labels, but because they are on not tented vias, they are probably also pogo pins for test points and for programming. So you could either program outside, just maybe using USB or using another interface, or since you already have some kind of test, maybe they have two different tests. One part of the assembly is just programming it, the other one is testing. Maybe they do both at once, it would be less expensive. I don't know. They could do both at once, but this indicates me that the microcontroller is probably here and these are programming headers, and while these are test headers. So they can have separate test and programming headers. So it looks, this is the board. Now I can de-zoom. So what do they use? Here is a flash chip, SPI flash Winbond 25Q. When you see 25, it means flash chip. This is the crystal for the microcontroller. The microcontroller is TI LM3S600. You have a microcontroller which starts with LM. I'm not aware of it. Let me check. LM3S600. Now I'm curious. I didn't know that there were microcontroller series started with LM. But I didn't play with a lot of TI parts microcontrollers, mainly the MSP430, which is a ridiculously ultra low power. TI LM6S300. Okay, it's not 6S300 maybe. No results. Okay, it's not 6S300, 65300. LM3 was 3S600. 3S600. I've put 6S. 3S600. Yes, it is. This is a microcontroller. Let me switch so you can see what I'm seeing. Full screen. Is this? Yeah. 6S500. This is the one. I don't know. Footprint is a bit smaller. Yeah, 48. So the picture is probably not the right one. I don't know. So let's have a look at the data sheet for it. Yeah, give me the data sheet. Here. Stellaris. Oh, I've heard about the name. What does it have? Is the figures. So this is the complete data sheet with all the peripherals. I want an overview. Give me a quick overview of what this thing is. RISC. Okay, it's an ARM M3. 50 megahertz, SAM2, that's normal for ARM M3. Hardware multiplication normal for, I think this is included in the M3. I wouldn't know why they added it, except if it's floating point, but there's no floating point. MPU, okay, this is unusual for M3 controller. You don't have generally a memory protection unit. Bit banding, that's normal in M3, so this is all M3 core. JTAG, it has, yeah, TI has a weird JTAG interface. So here there's the normal JTAG. No, TI has a, I think they, I don't remember. I remember they have not the usual 20-pin ARM connector, but something else. But here, JTAG. General purpose timers, 3 of them. Timers, 16-bit modes, then firm compliance. Well, I don't know what firm is. But yeah, watchdog timer, UART, 2 of them. I don't know what this type is. SSI, that's probably SPI, just a different name for SPI, so they don't pay fees. I don't know. But then you have I2C from Philips, and you can use the name, I think Atmel uses the name TVI, two-wire interface, so they don't pay I2C fees. Power, LDO, 2.5 volt. Operating voltage, quite unusual, but yeah. Target application DC motor. Okay, so this is a microcontroller. This is the microcontroller, a Stellaris microcontroller, and this will connect. But here you see FTDI. That's this way. This is the right way I went. FTDI. This is a USB to UART converter. So put the USB, which goes to the USB to UART converter, and this then only talks UART with this chip. So this is a serial DMX controller, and that's a bit sad. Oh well, it is probably an old design, and it is very reliable. That's useful because you could use a microcontroller that has a UART, which has a USB stack embedded into it, so you can speak higher speeds and different protocols than just serial. But this is reliable and probably good enough. This is why they use it. Probably on your products they don't buy FTDI anymore because this part is more expensive than this one, most likely. But and then on the other side we have 2 outputs. You see here these are optocouplers. And the idea of the optocouplers at DMX, it's quite important, is to have particularly on the dongle side, is that you disconnect the universes, the external connections, or all the devices electrically from this side. So anything which happens electrically on the bus, on the devices, maybe there's a short, maybe something explodes, you don't know if there's huge level, you don't break your controller. This is why they have this kind of isolation, but I don't see a complete I don't know if it is completely isolated. It must be. Something fell. And here, this is probably isolation for the power, because on this side you also need some power. So here you have the isolation for the data lines from 2 inputs and 2 outputs, 1 input, optocouplers. This is probably the voltage isolation. So yeah, B0505. So you have 5-volt input, 5-volt output with kilovolts of electrical isolation, and 1 watt output. Maximum 1 watt output is plenty sufficient to drive 1 or 2 optocouplers. And these transceivers, these are RS485 transceivers, because DMX is just an RS485 bus with a format on top of it to send some frames. 512 bytes of data, 1 byte of control, then some break code in between. And here we have a RGB LED to indicate the status. That will be also useful. I don't know what this is. I have no idea. ELGN137. This is a huge, I don't know what it is. It seems to be kind of a surge protection. You see a diode next to it. Here you also have, oh, wait, so here you have one output here. Oh, they even say what the color mean. But then you have two LEDs which are on the inside of the box, which you cannot see. Here one LED, here second LED, but they shine on the inside of the box. Here one LED, here the other LED, but they shine on the inside of the box. So in here, so you don't see anything. But it's weird that they left it on it. Yeah, voltage regulator. Ooh, 2 Farad beads, filters for the voltage before the voltage regulator. They take their power input serious. I don't know what this is. Let me have a look. GN136 or 37, 137, I think. Yeah, EL. I don't know what this brand is. EL. GN137. No results found. So this is not a very usual part. Or is it 6N and not 6 and not GN? 6N137. Okay, that exists. Also an optoisolator. Okay. You have two wave optoisolator. Did I make a mistake and this one is not an optoisolator? The 3? No, it doesn't make any sense. I don't know. I don't know. But yeah. Here we have 3 small maybe these are optoisolators for the transceivers, and this is another optoisolator. But I also have only 2 transceivers. Maybe these are dual transceivers, so they can. I don't. No. These transceivers can receive and transmit at the same time. So you, not at the same time, but they can receive and transmit, meaning that you can one to receive and transmit, and the other one to just transmit. And I don't know what this optoisolator is for, but yeah, you have 3 optoisolators. So maybe this is. These are to receive, and this is the optoisolator to transmit. I don't know, but I don't really care. And here you have a programming header, this is probably expensive, and this is a programming header. You also see the pins here, so you can debug using the test points, but they also really added a programming header. So they have a cable going up to it so they can programming it. So they probably don't program here, and this is to debug or to test the board. I don't know. They populated this header, so they paid for it, and it doesn't look like an inexpensive header. It's not like a usual IDC. But yeah, I think the only problem with this device is here. The micro USB connector has been slipped off, and this is usual for micro USB, and this is why I hate micro USB. It's ubiquitous and it's small and it replaces, but I rather prefer mini USB over micro USB because micro USB is just so fragile. So let's clean the pads and let's just add a connector and then connect to it. And this will be a really quick video, probably, because I don't see any other damage. I think it's only the USB which has been broken. Let me get my USB up here. SMD book, you can see it better. SMD book with USB, and I have plenty of different USB connectors, micro USB, some. So here we don't have any tab, it's just surface, and this is why it breaks, because it is surface. And I mean, you developing a product for industrial light, for light shows and so on, with people definitely very messy because it is event-based, so you have to be really fast at connecting everything together. You don't have a lot of time to have everything you need, so you will have a lot of stress here because you will connect fast and remove fast, and will be done very often, so it will break. So this is a bad design that they didn't connector with tabs through hole, so they can fix it. Like, yeah, these connectors here you see on the side, these are the mostly one I use. 4 tabs, not just 2 tabs, but 4 tabs. Here they have 2 SMD tabs, not even 4, so lazy. These are with 2 tabs. Here we have with 2 tabs, you see 2 mounting holes, and I know I have some without mounting hole. 2 mounting hole, USB-C, 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 USB-C. I don't have. I think I had a bag with 24 different connectors. Maybe it's not the one here. Maybe it's my other USB bag for debugging, where I don't count the parts. Here my USB box, another one. Micro USB, but these are cases. Mini USB, USB-C, USB Type A, Type A, Type A, USB micro, but not the one I need. Okay, I don't know where my bag of USB connectors is, so we'll use the next best one. I'm sure I bought plenty of them. Maybe I just lost them. So 2 tabs. Let's use one with 2 tabs and break 2 tabs. 2 plus 2. Why 2 plus 2? Ah, there are 2 on the back. No, we won't use this one. Let's try to use this one. And just bend the tabs on the side to know if I can solder on it. It's not the right connector. Let's make it work. I will also, to remove the stress, I will add a blob of epoxy on top of it, because I'm sure if it broke once, it will break again. So this will be connector. The pitch is all right. I will try to unbend this move. Let me move the camera. Okay. Oh, some needle pliers. I hope it's not fragile, too fragile. One, 2. Will it fit? It fits on board, and I can solder on the tabs. Yeah, so that will be good enough. Let's do that. First, let's clean the board. So, solder wick. Up. I need to clean the surfaces of the PCB, so I can actually, because there's solder on it, so they are brass. And because they are oh, they tried this. There was a pad. Okay, so they did try to mitigate. Here you see there's a surface where you can solder it, and here there was a pad on where now the only FR4 is exposed. So here they had a lot of solder to try and hold it, and still with that it did break. So I will really have to mitigate. So solder braids, we cut it so it doesn't go all the heat away. Then we have tweezers with ceramic tips, so we don't draw the heat away again. And because this is cheap solder without any flux on it, I need to put flux also. And now we need to clean the pad, so to remove the solder, so I can have my part flat on it and I don't mix the 2 different type of solders. Probably this is lead free, but since I'm repairing, I will use lead based because it's easier to solder, and I think for repair, at least for telecom repair, leaded solder is accepted. No need to, oh, okay. Even this pad has been ripped. So there was a huge force. So I will have to put some epoxy or something like that on top of it so it doesn't break again. And I'm sure that it might break. Okay. The pads, are they? Yeah. I'll try to tack one pad. Let's give. And then, yep, so plenty of solder. This is just to tack one pad so it holds on the board. Okay, so it holds on the board. I put more flux because it is tiny and my soldering iron has a large flat tip with a well. So it won't be easy. And now I can solder correctly on the other side. Oh, there is a kind of rift. I did not solder it correctly. Okay, now there's too much solder. That was kind of expected. Try with more flux. And try to remove the solder with a soldering iron. We don't need to use any solder wick. This large surface on the soldering iron should be sufficient. Maybe you want to see what I'm doing. And in between the pins, I just use the soldering iron to throw away the solder, because the solder likes to stick to something which is warm. In this case, it's a soldering iron. So this looks fine. I need to clean it, but let me solder on the side. There is not a lot of copper I can use, but at least it will hold tiny bits. Okay, that's one side. You're not seeing anything. That's the other side. So yeah, the tab is on it, but this will not hold for long. So I need to make something so it holds for better. But we can clean. Since we will use epoxy, we will put some things in it. Some things on the board, and because we put some things on the board, we need the board to be clean. So alcohol to remove the flux, and there's cotton swabs. Not there. There's not cotton. It's synthetic, lint-free. And with that, I can brush the board correctly. But before we put anything on it, I want to check if it works. So we just need to recognize, yeah, it is soldered on it. It is not the best soldering job I did, but it should be fine. Let's get rid of this. Don't need the USB box anymore. Okay, the journal is on. let's try to connect and see if it works. Here I have micro USB cable. What does my... Oh, I am afraid to press too hard on it. Why don't you... Well, this connector is not very good. Okay, no. Ah, there's 2 green LEDs. This is a good sign. No, here no LED. And the FTDI is recognized. FTDI will have libTTY USB 2. So yep, this device is recognized. I think everything will work. Now let's prepare the epoxy and put a blob on it. I do have new epoxy, which I think is better than the cheap, extremely cheap one I bought. But for now I want to finish with the cheap one I bought. I want to empty it before. So let's use, yeah, this 2005 industrial thing I got from China. Well, not too cheap, and we'll use that. Let's put a micro USB cable inside while I want to put the cheap one. No. Yeah, now let me get the cheap one so I can stress it without me worrying that the cable will be broken. And yeah, that's one of the problems with micro USB. I will put a lot of epoxy, but there are holes on it, so I need to put a connector inside, plug inside the receptacle, so the connector is not cluttered and doesn't allow any header to go in. So now one side will come out, plenty of it. Once one side is done, then I don't know why the other side will start. And this is getting hard even. Come on, other side. You have to come out. Just one side is not good. I need the 2 parts for the epoxy to work. Okay. And I don't like that they don't come synchronously, because this epoxy cues really fast. And that already makes bolts. Not good. Okay. Let's try to put some epoxy on it. To smear it all over. So we have a rigid connector. And I will also have a kind of a light stress test by hand. But up. Okay, this epoxy is garbage. It doesn't stick on anything anymore. I don't know if the whole tube is garbage. I did something wrong. Let's try a new part here. If I mix this, no, it balls up and then it doesn't stick anymore to the paper. Okay. I think this epoxy is kind of dead. are not good. Let's try with other epoxy and let's see if there's a difference with a bit more expensive one. Not too expensive neither. So let's close this. Here, this is the next one I got. It's also not the super expensive one, but it looks a bit better than the one I have, than the extremely cheap one. Up. This is open, is it? Yeah, it is. Oh, it's a lot more fluid already, and they have a distance between each other. So this is a point that there's no distance. So when I'm playing with it, I put from one part on the other, and then it clutters the output. Here we have two parts which have a distance in between. Oh, you don't see it. Which have a distance in between the needles. That's already a better design. Oh yeah. Just mixing it already feels better. Okay. So you know what I do with this one? Up in the bin. And I think I used ultra fast. Yeah, I had a choice between ultra strong and ultra fast. I used ultra fast, meaning 5 minutes. And this one is already, the one which I just thrown away, is already completely dry in 1 minute or so, which I don't find enough. This is 5 minutes, which is, yeah, I see it's already getting hard, but not too hard. I think 5 minutes is a good time. So, oh, it flows a lot better. Okay. Don't use the cheap one, just use this one. Oh, it flows a lot better. Like it's... And yeah, I didn't use the ultra strong one. I think strong is good enough. Just hope I'll be able to remove the connector. The plug afterwards, I think so. So now we have to wait. Oh, it feels so liquidish. It's a lot better. Let's put more on the top. So we create a strong thing. And yeah, I don't think I'll be able to repair it again once because I'm not sure how we'll get rid of this one. But this should be strong. So we have to wait 5 minutes. There's nothing to do, and I think then the repair is finished. I don't want to spend hours setting up the software to see if it works. There's nothing which looks wrong, so it should work perfectly. Just have to wait for it. And then I will also put a sticker. Don't be a brute. Okay, that's plenty of epoxy. Yeah, we just have to wait. So ultra fast is normally 5 minutes. These were my toothpicks. It's not written. How long? $2K epoxy. I don't know if it's two tons. It smells also a bit better. But here we have a test strip. Once this test strip is dry, we'll be fine. So there's not a lot I can do now, except wait. And there's not a lot of story. I won't show you the product because there'll be a video on it afterwards. And I didn't have to use the multimeter and so on. Also, the singular thing on the side are not interesting. I can clean the stuff. Maybe I can try to set it up. Do I want to set it up? Too lazy. I have no doubt it will work just fine if the USB is recognized. So the soldering iron, before I switch it off, I clean the tip, I switch it off, and I put solder on the tip. So the tip gets a protection layer and doesn't oxidize that fast. Screwdriver, we still need it. Pliers, we don't anymore. Spudger, it's fine. Up, this goes here, this goes here. This goes here. Up. You see this epoxy? The one which I used before is really hard. Not everything, but almost everything is hard. It's too fast. It's trying too fast. This one is far away from being hard. And it's spreading a bit too much. I hope that it's stuck where it was, but it is spreading. Well, I hope that it helps putting a bit of the stress off on the connector. Yeah, there is still very liquidish. Yeah, 5 minutes. We'll have to wait 5 minutes. It's a bit boring. There's nothing I can do. I can show you. Let's close the stream. I think they'll be fine. I think this is fixed. I don't see anything else. If it's not fixed, I will make another stream. But for now, this was a very short one, but at least you see the repair, and it's been a long time since I didn't do any live video, so that's it. But yeah, we'll close the video. If there is something else which is broken, I will make another stream. If not, then consider it as a success. Okay, enjoy the rest of the day.